We've been thinking of LLMs as having learned from a lot of text on the internet to predict the next word. But when you prompt an LLM, it doesn't just predict the next word on the internet, it actually follows your instructions. So how does it do that? In this optional video, we'll talk about the technique called instruction tuning that enables LLMs to do that, and then also a technique called RLHF, reinforcement learning from human feedback, that has been instrumental to making LLMs outputs more safe. Let's take a look at what these techniques do. We've discussed LLMs as having been pre-trained on a lot of text like this. My favorite food is a bagel with cream cheese. And so an LLM trained on data like this will be good at repeatedly predicting the next word based on what text on the internet sounds like. If you were to prompt an LLM with a question like, what is the capital of France? It is quite possible that it will reply, what is the capital of Germany? Where is Mumbai? Is Mount Fuji or Mount Kilimanjaro taller? Because you do see lists of questions on the internet about, say, geography. So if you see a web page that says, what is the capital of France? It's actually quite plausible that what comes after it is, what is the capital of Germany? But this isn't the answer you want. You wanted to say that the capital of France is Paris. So in order to get an LM to follow instructions and not just predict the next word, there's a technique called instruction tuning, which is basically to take a pre-trained LLM and to fine-tune it on examples of good answers to questions or good examples of the LLM following your instructions. So we may give it a question-response pair like this. What is the capital of South Korea? And fine-tune it given this input prompt to output the capital of South Korea is Seoul, or help me brainstorm some fun museums to visit in Bogota and fine-tune it to an answer like this, or an instruction like write a haiku poem about Japan's cherry blossoms and fine-tune it to generate that. And to try to make this safer, we can also include some examples like tell me how to break into Fort Knox. Fort Knox is a very secure facility in the United States that stores a massive amount of the US Treasury's gold. So trying to break into Fort Knox would be a terrible idea. Please don't anyone try to do that. But I think a good answer for the LM to output would be something like, I can't assist with that, or please don't break the law. So given a data set like this, you can then fine-tune a pre-trained LLM on a set of good answers to different prompts. Specifically, given the example about brainstorming museums in Bogota, we would turn that into a set of inputs A and output B, where first the input A will be that prompt, and the first word it should learn to predict here is sure, and the second word is sure here are some suggestions, and so on. And when you fine-tune an LLM on a dataset of prompts and good responses, then the LLM will learn to not just predict the next word on the internet, but to answer your questions and to follow your instructions. And this will do okay. But it turns out that there's a technique called reinforcement learning from human feedback, or RLHF, that can improve the quality of your answers further. Many companies training LLMs want the LM to give results that are helpful, honest, and harmless. Sometimes we call this the triple H. And the technique RLHF is a way to try to accomplish that. The first step of RLHF is to train an answer quality model. In other words, we'll use supervised learning to learn to rate the answers of LM. For example, given a prompt like advise me on how to apply for a job, we might have an LLM generate multiple responses, such as, I'm happy to help, here are some steps to follow, and then have a bunch of useful steps after that. Or it might say, just try your best, which is not that hopeful, but not that terrible. Or it might say, it's hopeless, why bother? So that's clearly not a great response. And we would then get humans to help rate these responses according to how helpful, honest, and harmless the LM's output is, so that better answers are given higher scores. Where the first really helpful answer might get a score of 5, the second so-so answer might get an intermediate score, and the final answer, which is terrible, would get a very low score. And if we treat the responses and scores as the input A and the output B for a supervised learning algorithm, Then we can train an AI model using supervised learning to take as input the response from an LLM and score it according to how good the response is. The second step of this RLHF process is to then have the LLM continue to generate a lot of answers to a lot of different prompts. And we now have this AI model to automatically score every single response that the LLM has generated. And this can be used to tune the LLM to generate more responses that get higher scores. The reason this technique is called reinforcement learning from human feedback is because the scores correspond to the reinforcement or the reward that we're giving to the LLM for generating different answers. And by having the LLM learn to generate answers that merit higher scores or higher rewards or higher reinforcements, the LLM automatically learns to generate responses that are more helpful, honest, and harmless. So that's how an LLM learns to follow instructions. The first step is basically fine-tuning, where you fine-tune it to follow instructions and to answer questions. And then second is RLHF, reinforcement learning from human feedback, to further train it to generate better answers. In the last final optional video, we'll also take a look at some cutting-edge ideas in the technology development of LLMs. Thanks for sticking with me in this video, and I hope to see you also in the next optional video.